Welcome back everyone. In this video we're going to discuss linear equations in two variables. Here we'll be looking into application based problems. So without any further ado, let's get started. Let us see the first question shown on the screen. A boat goes 60 km upstream and 24 km downstream in 6 hours. It can go 12 km upstream and 36 km downstream in the same time, that is 6 hours again. Find the speed of the boat in still water and find the speed of the stream. So one thing that we have to understand is, let's say this is your stream, okay? Downstream means along the stream. If the stream is passing in this direction, then you are also moving in this direction. This is downstream. Whereas if you are moving against the stream, then it is called upstream. Okay, now one thing that we have to understand is, obviously if you are moving along the stream, okay, then your speed will be increased. Okay, your speed will be increased. Whereas if you move against the stream, okay, against the current is in this direction and you are moving in this direction, so obviously your speed will be reduced. Okay, so if your speed is, let's say, x, and the speed of the boat is x and the speed of the stream is y, then for upstream, that is against, it'll simply be x minus y. Whereas for downstream it will be added, okay, x plus y. Okay, so with this concept, let's try to do this question. Let the speed of the boat in still water be x. Okay, that is if there is no current. Okay, if there is no current, then the speed will move with the speed of x km/h, and the speed of the stream be y km/h. That means the stream or the current is moving at the speed of y km/h. Then according to question, in the first case, time required to cover 16 km plus 24 km upstream and downstream is equal to 6 hours, right? 16 km upstream and 24 km downstream. So now this is time. The formula of time is distance by speed. Okay, so distance is 16 km for upstream and speed will be x minus y as discussed here, whereas for downstream it will be 24 and it will be x plus y, which is equal to 6. This implies, let's take x minus y to be u and x plus y to be v. 1 by x minus u, 1 by x plus y. So 16u plus 24b is equal to 6, where 1 by x minus y is equal to u and 1 by x plus y is equal to v. Also in the second case, time required to cover 24 km upstream and 36 km downstream, we get 12 by the speed, 36 by the speed. Again, for upstream means against, so subtraction. Downstream means along, so addition. Okay, so the speeds will be added, speed will be subtracted here, it will be this. Okay, now we'll be using the elimination method. So we will try to make the coefficient of the u same. Okay, so 12 and 16, if you take the LCM of 12 and 16, you get 4 3s are 12, 12 4s are 48. Okay, so here we're going to use a shortcut, subtracting equation 1 into 3. If you multiply this by 3, then this becomes 48. So equation 1 multiplied by 3 from equation 2 multiplied by 4. Okay, this equation will be multiplied by 4 because 12 4s are 48 we get. So if you multiply equation 1 by 3, this is what you get. If you multiply equation 2 by 4, this is what you get. Since this is subtraction, the signs will change, that is this two will get cancelled. 144 minus 72 is 72v, and if you solve this, you get v is equal to 1 by 12. Now substituting v is equal to 1 by 12 in the first equation, that is equation 1, we get this. If you solve, you get u is equal to 1 by 4. So this is v and this is u. From here, let's find x and y. So we have already found that v is equal to 1 by 12 and u is equal to 1 by 4. Now we know that v is equal to 1 by x plus y, u is equal to 1 by x minus y. If you solve this, you'll get x plus y is equal to 12, x minus y is equal to 4. So we see that the coefficient is same and opposite in sign, so we will add equation 3 and equation 4 and we will get this. If you solve, this two will get cancelled. 2x is equal to 12 plus 4 16. If you solve, x is equal to 8. Substituting x is equal to 8 in equation 1, we get 8 minus y is equal to 4 and y is equal to 4 km per hour. Therefore, speed of the boat in still water is 8 km per hour and speed of the stream is equal to 4 km per hour. Let us see one more question. 4 men and 12 women can do a piece of work in 4 days, whereas 4 men and 27 women can do a piece of work in 2 days. Find the number of days required to do the work by 1 man and 1 woman separately. Let us see the solution. Let the number of days taken by 1 man be x and the number of days taken by 1 woman be y to complete the work. Now in the first case, 1 day work of 4 men plus 12 women has to be equal to 1 day of the total work. Okay, so 1 day work of x men will be 1 by x, whereas 1 day work of y woman will be 1 by y. Okay, since there are 4 men, it will be 4 by x, 12 by y is equal to 1 by 4. Okay, since there are 4 number of days, so if you substitute 1 by x to be u and 1 by y to be v, this is what you get. Similarly, 1 day work of 4 men and 27 women will be 1 day of the total work, right? 1 day work of the total. So again, 4 by x plus 27 by y is equal to 1 by 2. If you solve this, you get 4u plus 27v is equal to half. Now since the coefficient is same and the sign is also same, we will subtract equation 2 from equation 1. If you do this, this is what you get. Since it is subtraction, the sign will change and this will get cancelled. If you solve it, you get v is equal to 1 by 30. Substituting this v in the first equation, you get u is equal to 1 by 60. Basically, 1 by y is equal to 1 by 30, that means y is equal to 30. 1 by x is equal to 60, that means x is equal to 60. Therefore, 1 man can do the work in 60 days and 1 woman can do the work in 30 days. With this, we conclude our video. Link to more solution to numericals is given in the description. Thank you everyone for watching. I hope to see you in my next video. Take care everyone.